Hi, everyone. Thanks for coming. This talk is about HyperCard. And HyperCard was a software authoring tool that was popular on Macintosh from 1987 to 2004. Danny Goodman wrote probably the definitive book on HyperCard, and he used the phrase programming for poets. And the reason he used that phrase is because he was trying to make the point that HyperCard made it easy enough for almost anyone to program a computer, even poets. And so that would open up the world of programming computers to a much larger audience. HyperCard was created by Bill Atkinson and Dan Winkler, and they donated it to Apple for free on the condition that Apple would release it with every Macintosh sold. They would distribute it with every Mac sold. And so it was distributed free with every Mac from OS 6 through OS 9. It had kind of a weird history. Apple spun off their software division for a while there into Claris. So HyperCard went with Claris when they got spun off, and then Apple sucked them back in, and it came back. And it just never really got a lot of attention. And I don't know why that is. But Apple never invested a lot of effort into it, so it kind of just sort of died off. And it's no longer distributed with Macintoshes, although you can still get old copies of it and run it in emulation mode on modern Macs. HyperCard was sort of the first implementation of HyperCard, but there were a number of commercial copycats that came along. And I'm not going to cover those, but they're still around, and some of them are still supported. If you look up HyperCard on the Wikipedia, you can find links to the websites for those other products. And just to clear up any questions, this presentation, instead of doing it in PowerPoint or some other presentation manager, I've done it in HyperCard. So everything you see up here will be HyperCard. The policy on questions is to ask them anytime you have them. I want to try to keep it informal, with the exception of this slide. This is sort of the overview slide, so I'm intending it to raise a lot of questions that I won't answer until later. So if anything here is confusing, wait till a later slide. I hope I'll clear it up, and if I don't, then by all means ask. So that first slide was introductory, but I didn't really answer the question of what HyperCard is, and that's partly because it's a very difficult question. There's a few things in the world that are so unique that you can't really describe directly what they are. You can only describe what they're like or what they're not. And so that's what this slide says. It's a description of HyperCard without being a definition. HyperCard is like a fourth-generation graphical programming environment. Back in the 90s, we had the concept of fourth-generation languages, which were generally a graphical user interface editor together with a scripting language that made it easy for programmers to get a lot of stuff done quickly. When the Macintosh came out, it brought with it sort of a new user interface model, but that was backed up by a new programming model that they called event-driven programming. And the idea was that these different events would happen, like the user would pull down a menu or click on a button or something, and the system would report that to your program, and then your program could take whatever action it needed to take based on that. So HyperCard is like that. It's a message-driven, event-driven programming environment. It has its own built-in programming language called HyperTalk, which is an interpreted language. HyperCard is also like a simple database. The metaphor for HyperCard is that it's like a stack of index cards. So if you imagine a stack of index cards with writing on each one, you could put one record's worth of data on each card and then do things like sort the cards or filter the cards to find the ones you want or reorder the cards. And so that's the basic metaphor that HyperCard is getting after. And with that metaphor, you can implement database-type programs. It's also a hypermedia browsing or presentation tool. Like I said, this presentation is done in HyperCard. But HyperCard supports graphics, text, icons, sounds, and links in between them. So you can really build a really rich hypermedia presentation if you want to. And because it's so good at supporting those types of UI elements, you can use it to build UI prototypes. A lot of times, you want to build a Macintosh app, or back in the 90s, you wanted to build a Macintosh application, and you would write it in C or Pascal or whatever. but it was a bit cumbersome to implement the program. So you might do a prototype first in HyperCard. And this last bullet point, I said it's like AppleSoft Basic. It's not really like AppleSoft Basic, except in two ways. As I mentioned, it was distributed free with every machine, just like AppleSoft Basic was. And it's pretty easy for a beginner to learn, which was another feature of AppleSoft Basic. So it's sort of analogous to AppleSoft Basic. When you had an Apple IIe, you could count on AppleSoft Basic being there, and you could count on a fair number of people knowing it. And that's sort of the same thing that HyperCard was for Macintosh. It was on every machine, and it was accessible to most users. A couple of things it's not. It was popular at the time to say that HyperCard was sort of an object-oriented system, and I don't think any object-oriented programmers would agree with that. It's really not object-oriented, but it's also not a procedural programming language, so it's in this weird spot in between. It's a little bit difficult to characterize, but later on we're going to see some examples of HyperTalk, so maybe you can make up your mind for yourself. And the last thing it's not a really good tool for any of those things in the top section. It's okay at all of them, and it's really easy to use, but it doesn't get its power from being the best at anything. It gets its power from being flexible and easy. Okay. So how does it do all that? I already mentioned that the metaphor is that you have a bunch of index cards that you put in a stack. In fact, HyperCard programs are called stacks, and each screen in a stack is called a card. And you can think of the cards as index cards, but there's a little bit more richness to it than that. In HyperCard, the cards are transparent, and they have an opaque background beneath them. And so the stuff that's on the background shows through the card, and then what the user sees is everything on the background plus everything on the card, and that's sort of what is visible. And the reason for that is because you may want to have the same thing on a bunch of cards, but it would be extremely annoying to paste a copy of that onto every single card. So the background gives you a way to share elements across multiple cards. For example, you may have noticed that the header is the same on every one of these cards, and the footer is the same. Those are actually on the background, and we can demonstrate that by going to the Edit menu and saying Background. It looks like everything disappeared, but it didn't. Everything is still present on the card. It's just that what we see now is only what's on the background. So these are the things that are on the background. And if I switch back to the card, these are the things that are on both the background and the card. My last point here is, yes, this gets very confusing. It's very easy to forget whether you're on the card or the background when you're putting something onto a HyperCard stack, and very often you get it in the wrong place and you end up moving it to the other place. To help clarify whether you're on the card or on the background at a given time, they very helpfully put hash marks in the menu bar. That's the only way you know that you're on the background. So that's a source of confusion for sure. Okay. Ordinarily, a programming environment has sort of two modes of operation. They have the construction mode, where the programmer develops the program, and then there's a user mode, where a user interacts with the program. And in a language like Java, these are very separate environments. In fact, you edit a program in Java, and then you go through a compilation step, and that produces an executable, and then the user runs the executable. And they can't see the programming environment at all. In some other languages like Ruby, there's a little bit more back and forth between the two environments. But that wasn't good enough for HyperCard. They had to have 5 levels, and the 5 levels are listed here. These names are what Goodman put in the book. I don't know if those are official HyperCard names. I know that HyperCard uses user level 1 through user level 5 to indicate the levels. And the user level is set programmatically by the stack developer. So when you launch a stack, it's going to set the user to a certain user level and restrict him to, at user level 1, all he can do is read the stack. He can't do anything. At user level 2, he can enter data but can't change the structure of the stack. And then there's painting tools that come with user level 3, and then user level 4 lets you add buttons and fields. And then if you want full programming, that's user level 5. So this is another slide about user levels. I'm going to start by bringing up the message box. And this is sort of like a command line for HyperCard, where you can type a HyperCard command and the system will pick it up and execute it right there in real time. And if we want to set the user level to a certain level, we can say set the user level to 1. Can everybody see the text? Can anybody see the text? It's probably pretty small. Okay, so if I hit enter, you can see that the user level gets set to 1, and I can't do anything now. I can't change anything. I can click the buttons, but I can't make any changes to the stack. And if I set the user level to 2, now you can see that my cursor has changed to an I-beam because I can edit the text in the stack, and I can delete stuff, and I put a field on this card so that I can type in here. So that's user level 2. User level 3 lets us use the paint tools, and the paint tools are pretty cool. I can switch. They're pretty primitive by today's standards, but they were standard at the time. Like here's the pencil tool. If my cursor changes to a pencil, and I can draw pencil stuff. And here's one thing I thought was really cool when it came out: is you can tear that menu off and use it as a palette. And I know it's not impressive today, but in 1987, I thought that was pretty hot. I'm going to switch to the background for a second to sort of illustrate the point I was making before. If I draw a bunch of stuff on the background and then switch back to the card, you can see that the background shows through and mixes with what's on the card. So you get to see both things. Let's see, I'm going to close this. User level 4 lets me add buttons and fields. So I'm going to switch to the button tool, and I'm just going to draw a button and then double click it, and this lets me edit the properties of the button. I can change the style to be like a round rect, and it gives you a preview. I can say show the name, and auto highlight lets me it'll highlight when I click it. And then I can do stuff like change the text style of the font on the button. I can assign an icon to the button, and it ships with a library of icons. If I click on tasks, this lets me assign different actions to that button. So when I click on the button, I can say, take me back a card, or take me to the next card. And you can do other stuff. You can have it launch an application. You can have it play a movie, etc. So what did I do? Next card. So just as easily as that, I've made a new button that will take me to the next card. And so you can see that even without being a programmer at all, you can make something useful in HyperCard just by having user level 4. Before we leave this card, I want to switch to user level 5, and this is what lets you do programming and look at the scripts. I'm going to bring up the script of the background. Every button, every field, every card, every background, and every stack can have a set of, they call them handlers, that comprise the script of that object. And so here's the script of this background. I think the card script is empty. And we're going to see more about the programming language later, so I won't go into that in detail right now. But to go to the next card, instead of clicking the arrow button that I already assigned, I'm going to use our brand new button and demonstrate that it does, in fact, take us to the next card. So that's pretty cool, huh? The user level is really just a way of limiting the damage you can do. One thing I didn't mention about HyperCard is that any change you make immediately gets saved. So if you delete stuff, like I deleted text on that other card, that gets saved. And if I quit HyperCard and come back in, that's gone. So you can really damage your stack by accidentally or on purpose, deleting things that you didn't mean to. And that can be a problem. So setting the user level as low as necessary is a good practice. I'm actually going to get in there and erase this stuff because that's going to get in my way in the future. Okay. If we're going to write scripts in HyperCard, we have to understand messages and handlers. And so basically a message is something that HyperCard sends to your stack when a system event occurs. When I click on a button, for example, it sends an event called mouse up. When you let the mouse button up, it sends a mouse up event. Your stack can intercept that message as it goes past, and it can take action based on it. And that action is contained in something called a handler. And the names of the messages and handlers match up. So the mouse up event, the mouse up message, is going to be handled by the mouse up handler. So let's do a quick example here. I have a button called test, and if I click on it, it's going to put up a dialog that says thanks for the click. And then it's going to put up a dialog that says here's another message box. And what I want to do is look at the script of this button. And you can see what happens. Is this visible at all? Should I paste it into something that I can change the font on, or can you guys see this? Okay, good. So I have a handler called mouse up. It's going to, on the mouse up event, it's going to do the answer command. Answer is the HyperCard command to bring up a dialog box. And then it's going to do a command called do more work. Now, do more work is not a recognized HyperCard command, so HyperCard knows that must be a new message. So it's going to fire off a do more work message, and that gets handled down here. The dash dash at the start of the line is the comment delimiter, so we know this is a comment. And then the do more work handler just does the same thing. It puts up a dialog that says some more text. So this is an example of a system message that gets handled by a handler, and it's an example of creating a new user-defined message that gets handled by a handler. So this is pretty useful. You can put commonly used things into a common handler and then call it from multiple places. Okay. Now, we did a simple example there where the message got handled by the button that we clicked. But HyperCard's a little bit more advanced than that. You don't have to have the handler in the object that receives the message. In fact, there's a hierarchy that the message will travel through if it's not handled in the object that got the message. And the hierarchy looks like this. First, the message is going to go to the buttoner field that you sent the message to. If there's no handler there that matches the name of the message, it goes up a level to the card. And if it's not handled in the card, it'll go to the background. And from the background, it goes to the stack. Something I didn't mention earlier is that there's a concept in HyperCard called the home stack, which is sort of like your home page. It's supposed to be the place you go when you start HyperCard. And that stack sort of always sticks around in memory. And you can put handlers there if you want. Unfortunately, you can't control what home stack a given user is going to have on a given machine, so it's a bit risky to assume that there'll be a handler in the home stack. So it's a best practice not to put handlers in the home stack. And finally, messages can be handled by HyperCard itself. So I have an example on this page too. If we look at the script for the test button, it's going to do the same thing as before. It's going to say thanks for the click, and then it's going to put the word button in a card field that I've set up. So this is an example of a message going to the button, and then it puts the name button in this field. So I can clear this field. Because what I wanted to show is there's also this command called pass, which I will uncomment. And when you say pass a message, it's going to send it up the hierarchy. So after the button handles, this do trace message that I fired off, it's going to pass it up the hierarchy to the card. And if we look in the card, you can see I have another matching handler that's going to put the word card in that field. And then it's going to pass it on up the hierarchy to the background, and the background also has a do trace handler that can handle that message, and it's going to stick the word background in that field. And I've also got the same thing in the stack script. So we can predict what we see here will be the list of objects that handle this message when we click test now. And so it's going to tell me thanks for the click, and then it's going to put things in that field in the order that they happen. So this is just an illustration of how messages flow up the hierarchy. It should be obvious that once a message is handled, it doesn't get passed any further up the hierarchy unless you explicitly pass it. And this is a bit convenient. If I want all the buttons on a single card to behave the same way, I can put the the mouse up handler in the card script instead of the button script. For example, it gives you a way to plan where you want to put your scripts for best reusability. Okay. So now that we understand the messages and the hierarchy, we can talk about the HyperTalk programming language. And we've already seen some examples of it. And maybe you have noticed a few things about it, such as it looks a lot like English. You don't say x equals 3 plus 5. You say put 3 plus 5 into x. This is supposed to be a little easier for novices to read and learn. I guess if you're a poet, you would rather see put 3 plus 5 into x than something that looks like math. HyperTalk is an interpreted language, which is almost true. It is compiled on the fly, but the compilations are cached for the next time it gets run. So you get a little bit of a speed advantage by running the same script over and over. It has procedures and functions. Procedures are called handlers, which we saw an example of before. You can call other handlers from your handler. For both handlers and functions can receive input parameters, and then functions can also return a result parameter. Here's a bad thing. Variables in HyperCard only have two possible scopes. Either they're local to a handler, which, as you've seen, is a pretty small chunk of code, or they're global across the entire stack. And global variables are a bad programming practice. So that makes it hard to write really structured programs. They have this keyword global. If you stick that in front of your variable, it means that anybody anywhere can see that variable. And so it makes it very easy to accidentally mix your data when you didn't mean to. HyperTalk is pretty cool because it has what I'm calling a 1990 class debugger. It's not really thrilling or exciting by today's standards, but back then it was on par with other debuggers that were out there. It had breakpoints, and you could step through your code, and it was pretty cool. So you could get some stuff done. You had some challenges if you wanted to write really tight program code because it's interpreted and it has the variable scoping issues. And it's extremely irritating that it saves everything in your stack, even if you might want to roll back the changes that you made. But you could get some cool stuff done. Okay. So I think I'm on schedule for time, so I'm going to do this demo. I set up a bunch of buttons and fields on this card, and first I'm going to demo the simple buttons, and then we're going to look at the scripts to sort of see how they work. This set of buttons works together. It asks you what goes next on the list, and you can just type anything in the box, and it will add it to I called it shopping list. So we can add items, as many as we want, and it'll keep adding them to the list. When we get tired of adding items, we can clear the list. And if we decide to put integers in the list, we can click the total button, and it will report the total of whatever numbers we put in there. And this is a really simple program, but I wanted to show you some of the ways that HyperTalk works. The first one was the thing that prompts us to add something to the list, and it uses the command ask. We saw answer before, which puts a dialog box up with a text string. If we say ask instead of answer, that's going to ask you for input and then accept your input. When it gets your input, it sticks it into a special system variable called it. So you say ask what's next on the list, then you say put it after the card field shopping list. So you can see that it reads a little bit like English. The ampersand is the concatenation operator, and there's a keyword called return, which puts a carriage return after it. So what it's going to do is take whatever we typed in and stick that thing plus a carriage return after the card field. The clear list says put empty into card field shopping list. Empty is another system reserved word that means exactly what it says. If you put empty into a field, it's going to empty the field. And then here's the one that you click to total up the list of numbers. This is going to look a little different from other programming languages, but like we said, it reads like English. First thing we do is put 0 into a variable called total. And then here's how you do loops. You say repeat with I equals 1 to the number of lines in card field shopping list. So it gives you a simple way to do things like interrogate a field and ask how many lines are in it. You say the number of lines. And then, if you want to accumulate something, you say add line I of card field shopping list to total. This is how you accumulate a total. Here's the end of the loop, and then you say, put total and total after card field shopping list. So that's a simple example that shows some HyperTalk commands. Here's a cooler example. This button is draggable. You can drag it anywhere, and when you let go, it stays there. And the cool thing about this is that, when I talked about clicking a button before, I mentioned the mouse up event. But you actually get a number of events when you click the mouse. When you push the button down, you get a mouse down event. And on mouse down, I'm setting the highlight to be true, so that's going to highlight the button. When you let the mouse up, you get a mouse up event, and that's going to set the highlight to false. But while you hold the button down, you get this event called mouse still down. So you're going to get a series of those as long as you hold the mouse down. And what this says is set the location of me, and me is a special word that means whatever object the script lives in. And this is the script of that button. So it's going to set the location of that button to the mouse loc, and mouse loc is another system reserved word that means whatever location the mouse is at. So you can see what happens when I do a mouse down is it highlights the button, and then while the mouse is still down, it's setting the location of the button to be the location of the mouse. And then when I let go on mouse up, it unhighlights the button. So that would be pretty hard to write, I think, if you were doing it in a procedural language like BASIC or something. But you can see with the event model, it's just really 3 lines of code in 3 different handlers. So the cool thing is that the system takes care of things like interacting with your mouse, interacting with the menus, and informing you of what's going on so that you can manage just the application part of your program. Okay, so this button is the one with the complicated script, and this is intended to show a couple other things. Here's the if-then syntax. You say if, and then parentheses, and you put your Boolean condition in there, and then the keyword then, and you can have an else and an and if. Another thing it does is you can test for special keys like the command key and the option key and the shift key by saying, in this case, if the option key is down. So that's very English-like. In a lot of programming languages, you have to go through some special tricks to find out if the user held down the option key. But in HyperCard, you just say, if the option key is down, then do one thing, otherwise do another thing. So you can see that if I click it, it's going to go through the path that doesn't have the option key. And if I hold down the option key, it's going to take a different path through the script. So the takeaway from this slide is that HyperTalk is indeed very English-like. Once you find out about these keywords, it's pretty easy to remember how to do what you want to do. Okay, so I think we have time for a cooler demo too. Back in the day, when you wrote Macintosh programs, a chunk of it was written in code, whether that code was Pascal or C or HyperCard. You had the code chunk, and then you had all your resources. And the resources in a Macintosh application were like the icons, the pictures, text strings, sounds, and so forth. And just because it's HyperCard and it's sort of a toy environment doesn't mean that you don't have access to all that Macintosh programming stuff. So we can actually run the ResEdit program and add stuff to our HyperCard stack. So to open the HyperCard stack with ResEdit, I'll just drag it onto ResEdit, and I can look at all the resources that my HyperCard stack has. And I've got one sound in my HyperCard stack. I've got some text strings, and this includes any text strings that I would add, plus a bunch of them that shipped with HyperCard. It's got icons. What else am I looking for? Well, what I wanted to show was if I go into the system scrapbook, I can page through here till I find something. Like here's a sound that ships with the operating system. If I just copy this sound, I can go into ResEdit and say, oh boy, create new resource. And I can just paste that, or I should be able to. There we go. And so now here's my sound resource. And I should have been able to give that a name. I wish I could see my menus. Nope. There we go. And so hopefully, if everything worked right, I can just save this and quit. And now when I reopen my HyperCard stack with HyperCard, I'll have access to that new sound. And I'll just switch through to my cooler demo. And I'm going to switch to the button tool. And I'll make this a rectangular button and give it a task to play a sound. And I can select new sound, which shows up now. And I'll just assign that task. And if I switch back, I should be able to play that sound that we just pasted in from ResEdit. So that's a pretty cool thing, to be able to just grab a sound from anywhere, stick it in your HyperCard stack, and slap a button on there. We did that in 60 seconds or something, and that's just because I was talking. So you can imagine if you wanted to build a library of sounds, you could collect them all and paste them all at once into a HyperCard stack and just make a ton of buttons. So that's pretty cool. Another cool thing is that ResEdit is used by, or it was used by, Macintosh programmers to do actual Macintosh programs. So the learning curve of HyperCard, it takes you from just editing text to adding buttons to assigning tasks to buttons, and then up into HyperTalk. You can script your stacks. But the learning curve doesn't stop there. You can start to work with ResEdit and get a feel for what it's like to do Macintosh programming, and you can move from there to writing Macintosh programs in other programming languages. So it's a good sort of a learning bed for Macintosh programmers. It's pretty cool. I'm going to go ahead and do the real-world examples slide. HyperCard was not extensively used to make a lot of production programs, but one famous example is the game Myst. It used sort of a hacked-up version of HyperCard to display pictures and let the user interact with the puzzles within the game, and it was pretty popular, so you might be familiar with that. The reason I know so much about HyperCard is because I worked at a company in the mid-'90s, the early '90s, to build a client-server system that would query IBM mainframe database and bring back the results and display it in HyperCard in tabular format as well as charts and graphs. And that was pretty cool because there were no tools in 1992 to build client-server systems. We had to do it from scratch, and we did it with HyperCard. And the user would click on things like, I want to see my product revenues by geographic location, and click OK. And HyperCard would build a text string that represented a SQL query, and it would ship that up to the mainframe, run the query, and get the results back in rows and columns, and then it would parse through those results and display them on the screen and even draw graphs. And so it was pretty cool. But we had a problem, which was it took a minute or two sometimes to process that much data. Because computers were slow and it was 1992. And so these executives who were getting these sales numbers were complaining that it takes up to 5 minutes to run a query. But that was actually a pretty good time because before they had the system, the way they would get that data would be to request a report from IT, who would run they'd write a custom query probably and run a report and deliver 500 sheets of paper to the guy's secretary, who would type it into Excel and draw the graph. And 2 weeks later, he would have his report. So 5 minutes, by comparison, isn't too bad. But because it was an online system and it was the executive who was, waiting 5 minutes, it sort of limited adoption. So that's my story about how I got involved with HyperCard. We actually didn't use HyperCard. We used one of the commercial copycat products that I mentioned on the first slide, which ran on both Windows and Macintosh. So we could develop once and then run it both places. It had color. I guess I should mention that HyperCard was very slow to adopt color. This is part of the lack of investment in HyperCard that Apple had. So it was black and white for a long time. And when color was finally added, it was a bit of a hack. It was not well integrated into the system. So that kept HyperCard from being as popular as it could have been, because nobody wants to, you know, in the year 2000, nobody wants to work in black and white. I heard a story that those tall buildings in Kuala Lumpur have their lighting controlled by a HyperCard stack. I don't know if that's true or not. I've never been there. HyperCard is very popular in education because it's easy to build fun things in HyperCard. So a lot of students use it. A lot of teachers use it. And the last example is the Whole Earth catalog in 1989 came out in electronic version. And there was almost 10,000 cards in the stack. It's 400 megabytes, and it would cost you $150 if you wanted it. So that's probably the most expensive HyperCard stack you could buy. So I have time for one more demo, but first I'm going to go through the references so that we don't have to come back here. This is pages for it has just the references. The Wikipedia is probably the best single source of information, but I highly recommend going to archive.org and searching for HyperCard, because some of the videos are really entertaining to watch. It gives a great picture of, you know, how computers and technology were seen in the mid-'80s or the late '80s. It's pretty neat. This stack itself should be available if you go to, let's see. .org, NOTACON, 2008, NOTACON, 2008 stack. It's a self-extracting archive, if you guys remember those. And it's also available in bin hex format if you're going to transfer it over a modem that's going to freak out if it sees a 8-bit character. Okay, so I'm going to do a demo real quick because I want to illustrate that you know, HyperCard can be used. Oh, I shouldn't have done that. HyperCard can be used to build an application very quickly. I'm going to build a Rolodex application right here before your eyes in about the time remaining. So I'm going to say new stack, and it's going to let me give the stack a name. And I can pick the card size. And the original default HyperCard stack size was 512 by 342 because that was the screen size of the original Macintoshes. So that shows kind of how far back this goes. So I'm going to go ahead and make a new stack. And so this is it. You just get a blank stack, and it's waiting for you to do stuff. So the first thing I want to do is I want to remember to switch to the background because I don't want to do all my work on a card and then have to move it to the background. And so the hash marks mean I'm on the background. The first thing I'm going to do is tear off my tear off menu because that's hot. And then I'm going to grab the field tool, and I'm going to make a bunch of fields. And I'm doing this just by, I hold down the command key and then draw. And that, you know, lets me draw a field any size I want. And then I'm going to switch back to the text. Whoops. Objects only appear when you have the corresponding tool selected. So when I switch from the field tool back to the browsing tool, you know, every indication that I had fields on there is gone. So I want to switch back to the field tool, and actually I'm probably going to delete these fields. I'm going to do it once, and then just copy them. So I'm going to call this one name label. Remember, this is a Rolodex, so I'm just going to have name, email address, and keywords instead of having all the contact information and phone number and everything, because you get the point. So I'm going to make this one probably transparent, and I'm going to change the text style to Arial black, it says, 18, so that you can see it. And OK, then I'm going to switch and name. OK, so obviously I need to make that a little bigger. And I probably want to right justify this because it's a field label. Now you're probably wondering why I made a field to type the field label in there when I have this perfectly good text tool over here that I could type with. And the reason is because if I type with this text tool, it's going to make this a bitmap, and it's going to stick it on the card or the background. In fact, I just stuck it on the card because I forgot to switch to the background. So I'm going to undo that. And once it's a bitmap, you can't do anything with it except erase it. You can't edit this text. You can't move it around. It's it's stuck. And I'm assuming that my boss is going to come back and tell me that I need to change the field names or move them around or change the font. So I want to put it in a field instead of a text. So what I have over here, it says to make this a rectangle, Arial 18. Oops. And that's it. And then I'm gonna, I think if I, whoops, no, that's not it. There used to, if I hold down the Option key and drag, that copies the fields, so I can rapidly make fields. Now I do need to change the names of these because this is not the name label, it's the email label. And this will be the keyword label. This convention of camel case, I guess they call it, with each word of the name starting with a capital letter is sort of a Macintosh convention that got adopted elsewhere. So I'm going to lock the text of these fields. That was the wrong thing to do, actually, because I didn't type text in the other ones yet. So I need to unlock these. I can lock this. And the only reason I'm locking the text is because I don't want someone to come along and type in there, because these are my field labels. Okay. So I think that's all my fields. Next thing I want to do is add a couple of buttons. So I'm going to put those on the background. And I'm going to make a previous and a next button. And I'm also going to make a find button. So this is going to be called previous. And he's going to be a rectangle, and I'm going to set his icon to be, one of these arrows that looks like a previous icon. And here's one for next. Rectangle. And I'm going to give him auto highlight so that he highlights when I click him. And turn off shared highlight is for radio buttons. If you want a group of buttons to share the highlight property, you use that. And I'm going to give him a task of previous card. And then I'm going to give him a task of next card. And then this one is going to be my new card button. I'll make him a rectangle, and I'll give him an icon that looks like a new card somehow. This looks like I'm putting a new card in the stack. Now, there's no task that corresponds to new. So what I'm going to do is write some script. And to do that, I'm going to say do menu. Do menu just looks in your current menus and chooses menu options. So I'm going to say new menu, new card. And so if you look in if you look through the menus, there's a new card command. So any command that's in any menu, you can access it from a script by saying do menu and then the text of that. So when I say new card, it's going to create a new card. And then I also wanted to make a find button. So I guess a good icon for find would be like a, I don't know, magnifying glass or something. And I'll call this find, and I'll make it a rectangle, and I'll give it a script. And when I click the mouse up, I'm going to do an ask find what, and then I just say find it. Because remember, it is a special word that means the thing that came back from the ask, and find is the command to find something. How much easier does it get than that, right?
That's how Google does it.
Yeah. Okay, so now I'm going to switch back to the card level. And it looks a little sloppy because I didn't spend any time lining things up. But if I give my first contact a name of Mike, and I give him an email address of mike@example.com. And so the first thing we run into is layout issues. So that's easy enough to fix in HyperCard. I don't have to recompile any code. I don't have to say set the width of the field to 300 pixels. I can just drag it to the size I like. And then keyword friend. And then I want to create my next one, so I click the new button, and it looks like I've screwed something up. I have a background, foreground issue, I guess.
Text got set when it was on the card.
Yes. What I need to do is click this and say shared text. Shared text is the property that says this goes across all the cards in the background. So
You can just select over the box and do that option all at once?
I think you can do shift, yeah. And so it clear, yeah, so now I have to go through the horrible chore, and no, I can't multiple select. To answer your question, I have to unlock them all, and now I can type name, email, keywords. Okay, and now I can relock them. So, thank you. I told you it leads to confusion. Okay, so here's my new card. And I'll create another one. Okay, so now I want to find a contact, and I can just find my friends. And it'll take me to the first one, and it's hard to see with the way it's set up here, but there's a little box around friend because it takes you straight to the text. And so this was the first one. If I want to find the next one, I think the command is find next. Nope. Whatever the command is, it's find again, yes. Nope. Well, we don't know what that is, but it's in this book. Next will take you to the next card in the stack. But what I think you can do is you can mark cards. Each card has a property called marked, and I forget the exact syntax. You say something like mark all cards where card field keyword contains friend. I think that might be the exact syntax. And it'll mark all those cards. And you can't see that they're marked, but then you can do things like print all marked cards or delete marked cards. So it gives you a way to work with sets of cards. And using the sort of the data, the way that HyperCard is like a database, that's sort of like a working set of database records. So it's pretty cool. And I think that was about, well, it took 10 minutes to build the Rolodex application. And you know, it probably would have gone faster if I hadn't been talking through the whole thing. But you know, it's really fast to build an application. How long would it take you to build that using, you know, PHP and MySQL? Probably longer than 10 minutes. And I'm not going to try to pretend that HyperCard's as good as PHP and MySQL. It's certainly not internet-enabled. It's not backed by a multi-user database. But you can do simple stuff fast. And I don't know, maybe I'm not working with the right products, but it seems like the productivity that you get out of a fourth-generation thing like HyperCard just isn't in a lot of the tools that we have today. And it's a little bit of a missed opportunity that we maybe could have built some better you know, helper tools for the developers to increase their productivity. So I wish there was more products that had HyperCard-like features, even though I realize it's probably not a great idea to have something exactly like HyperCard that we're developing the internet on, for example. So that concludes my prepared remarks. Does anyone have questions? Anyone? Yes?
Is HyperCard able to pull anything out of other software? If you had an Excel table or something, could it pull data from it?
That's a great question. I'm glad you asked it. The short answer is kinda. HyperCard lets you build these things called external commands. And maybe you remember seeing the XCMD resource when we opened it with ResEdit. These are little chunks of C code or any language. You compile it down into an X command. And then HyperCard is able to use that command to do whatever you want to do in C. So what we used it for was to connect to a mainframe and run a SQL query. But you could use it to, flip over to Excel and grab some data and, pull it back. And even cooler than that, there's something that I sort of glossed over in one of these slides is the later versions of HyperCard. I don't know if the version I have. Yes, you can switch from HyperTalk to AppleScript. And AppleScript is sort of a system-level scripting language. It's shell scripting for Macintosh. And probably with AppleScript, you could say something like, launch Microsoft Excel, select cell A1 through F16, copy, and then paste it. So the answer is yes. It's not really built into the product or the language, but there's ways to do it. Sort of the vision that they had for HyperCard was it would become sort of the shell scripting environment for Macintosh. And that never took off because nobody really ever pushed that vision. But they did some cool stuff. And so you could build stuff that did stuff like that. But one problem with HyperCard is it's a bit unreliable. If something doesn't work, it fails in an unpredictable way. And that got to be a little bit irritating sometimes to programmers.
Do you know if there were any web browsers for Mac OS that were AppleScript?
I think that the way AppleScript work, I didn't bring that book, is there's different levels of support. Like all applications have to support things like launch and quit.
Right.
And then other ones could support application-specific things like, go to a web page. Yeah. So I don't know specifically of one, but it seems highly
I
conceivable.
was just pondering if there was an easy way to do something with the internet from HyperCard.
Sure. Yeah, that'd be cool. Is that about time? Okay, so thanks, everybody.